Okay, so hopefully everybody had a nice evening last night. And so here we are at the last day of the workshop. So today, this morning, we are going to start with reports from Breakout 3. And then we are going to move to Breakout 4 and then hear the reports from that. And then we're going to have 1 hour and a half for discussion and really sharing ideas and really trying to come up with some maybe key actions on the near and longer terms future. So let's start with the breakout. Yeah, Jonathan. Every speaker has 3.5 minutes, so there is a little increase in the time.
Oh, okay. All right.
Yeah, you can see the
Okay, sweet.
Hello. If it's shorter, it doesn't matter.
Perfect. What's up, Jonathan from Bigelow. So here are the Group A key points we talked about. So comparing shelf versus open ocean observing and modeling, they're both important, but on the shelf, it seems like data is sparse. And this could be for 2 reasons. One, it either exists and isn't findable, or it doesn't exist yet and we need to get to it. So part of this is because of granular funding structure. So this is money coming for urgent local concerns, and then maybe the observing stops after that funding runs out. The socioeconomic impacts on the shelf are huge also, so that's why I want to stress shelf observing. And then also having new simultaneous observations could lead to a better mechanistic understanding. So then we started talking about integrating observations and modeling. And the challenge is we need a national backbone to support this. So similar to observing efforts, there are individual modeling efforts that aren't consolidated. They're all, you have to go to each page to find them. There's no national infrastructure that serves these up. And so we kind of talked about this NIMS perspective that integrating observations and modeling is required for having climate smart management. So you need to think about observations from an application or state estimation perspective. And definitely want to stress that the workload can be shared internationally. Everyone's in it together, facing the same problems, and if we work together, this could help make things go smoother. And then we started talking about reanalysis products. I don't know how we got onto the topic of today's breakout session, but having a complete field of interpolated data can also help, but we need good observations to feed into these reanalysis products. But they're really good because they're metadata consistent, but they can't be treated as observations. They're model output. So I guess that's it. And if anyone else for the group has anything to say, chime in, but thank you so much.
Hello everyone, this is Tonton. I will present our discussion from Group D. So we talked about computational limitations and that we need ensembles of ensembles to better characterize the uncertainty in couple models. And in that category, we also need to figure out how many members do we need and how much computational resources we need. And also the questions extends beyond how many, what is the high performance computing resources that we need. It needs to be extended to the analysis time and storage and data sharing. So in terms of data limitations, we talked about that we need more data on the continental shelf, and we need to have the characterization of the data uncertainty, and we need to have more mechanistic studies, and there is this agency barrier that we need to figure out a way that people are willing to share data with each other. And the solution is that we want to advertise there are funding opportunities for data synthesis efforts. So if you're interested, you can take a look. And we currently have some data sharing repository that includes some, for example, Figshare. But one of the important things is that we need to, which has been brought up many times yesterday, is we need to uniform the data formatting. So we have to have consistent variable names and units. And when scientists is doing proposals, we should expect to set aside 10 to 25% of our project money and time to spend on data curation. And so the gaps in knowledge, we think there are, we have limited data along the boundaries, which includes land or water boundaries, sediment and water surface, coast and shelf boundaries. And we need to do more lab field experiments to figure out the rates, more rate formulations, and we may need to do multi-structure experiments so that's beneficial for the modeling. And in terms of leveraging modeling for prediction, we think that we need to do more comparison between the machine learning models and dynamical models, so that each group of the model can inform each other and should have a mutual improvement. And we can also use the machine learning to fill in the gaps of the observational data, and so that has the potential to improve the dynamical model as well. And lastly, we want to highlight that we need to encourage the collaborations with data scientists. So this will bring both the modeling and it's going to help with the prediction as well. That is all. Thank you.
Okay, I'm Matt Newman, talking for Art Miller, who just choked on his coffee. I don't think I will talk quite like Art would, though. So we basically have broken up our bullet points into the two main questions, and we started discussing just this general issue that there's a lot of high technical requirements to do this, to do some of these kind of forecasts, especially if we want to bring in machine learning. It's partly an engineering challenge, and we need the computer science expertise. We need to pull in people who would be interested in the field. To do sufficient ensembles for forecasting could be a real challenge, because you could run large multi-model ensembles where each model is running 10 to 20 ensemble members, forecasting out, say, 9 months, doing this monthly. That's just the climate side. Then you're going to want to drive related regional downscaling models, also increasing the ensemble size. And then you may have an ecological model hooked in as well, increasing the ensemble size. So it starts to become so large and potentially so unwieldy that it could be too large to be practically feasible. So one alternative we discussed is basically using smaller ensembles to determine some ensemble mean, and then trying to dress that with a appropriate probability distribution. That could be computationally more tractable. The downside of that would be if the environmental system is very path dependent, if it requires some information, not just about the statistics, but individual realizations, how the climate is evolving. It may be that we're going to be stuck having to do these ensembles, and we'll have to deal with that. But that could be a real potential problem. And then, of course, actually trying to figure out what the nature of the ecological model will be in such a system. That's also fairly uncertain at this point. That kind of thing needs to be developed, and it needs to be developed in a way that's at least somewhat realistic and captures the range of nonlinearities. But given all of that, we may not be able to verify the models, so getting the data is also an important issue, not just in terms of, say, developing the model, but then in order to test whether the model technique is predicting reasonably well, and that may be also a limitation. And that's particularly important because on the climate timescale, we tend to test our models by doing what are called hindcasts. We have data going back, say, 30 years. We can run a forecast model as if it were running in real time and look at how well it predicts, looking at particularly questions of whether the probabilities of different events it predicts match the observed probabilities. This has come up once or twice before. It's something called reliability. That'll also be essential for any probabilistic system, including one that predicts ecological variables. But again, that data needs to be there to do that verification. So I think that I'm just going to kind of leave it there because I'm out of time. But there's a bunch of other items there as well that I think are also relevant.
Let's see. I have to read this slide, so don't look at me. And I can't see it. So we talked about what everybody else talked about in terms of thinking about both the gaps and opportunities to kind of fill those gaps, and how to combine mechanistic and machine learning technologies. So. At the end of our discussion, we sort of went around and everybody kind of picked out their favorite thing that they really wanted to put on this slide. And so that's what this list is, less exactly a comprehensive list of what we discussed and more how we all kind of agree. And some of these were things that more than one person coalesced around. So a strong, there were a lot of pros for this idea of developing kind of hierarchical models. So in I think what we mean by that is different scales of complexity, interoperable models, that is to say where we can actually look at the impact of switching out these different levels of complexity models. Right now that can be a pretty challenging topic. And for maybe developing sort of test beds or frameworks in which we can look at an ensemble of models over a similar region and set of data to kind of more systematically evaluate and understand the model challenges and limitations. So we really thought that having the community invest in curated data sets, this is obviously going to be something that we'll talk about a lot today, but that having the ability to look at different sets of models and different sets of machine learning tools on a common quality assured kind of data set is really critical to understanding the different flavors of models and how well they operate and what are their limitations and strengths. So we discussed, just because we could, that there are some programs out there like NASA Exports that have focused on data synthesis and a common sort of data repository, and these might serve. There might be multiple or time series like BATS and HOT. These might be obvious low-hanging fruit to approach for this kind of work. We also kind of looked at, or one of the comments was with respect to kind of understanding that all machine learning approaches don't necessarily apply equally well for environmental science, and so kind of starting to understand some of the limitations associated with each one. I may have mischaracterized that comment, so you chime in if I haven't got that right. We had kind of a nice discussion about the need for the development of forecasts and who are the users. And so, there have been examples where products like wave forecasts are used extensively by surfers. They get to know their favorite models. They actually understand the uncertainty. And so really delivering forecasts that have the ability for the user to kind of see for themselves how well that forecast is operating seems to be really key for the uptake of that forecast. So the other one that was mentioned was sort of your Apple Watch and your air quality monitor, okay? When the user can tell whether the forecast was correct, they're more likely to jump on it and go. So there was really strong consensus over multiple people that there's this need for just really kind of almost moving towards best practices in ensuring that forecasts arrive with probabilistic estimates of their skill, their quality, and also this idea of conditional skill. And I'm not sure, I realize that there's a lot of terminology that we've been throwing around that maybe isn't common. So I asked Andrew this morning on my way in, I'm like, now, do I know what conditional skill is exactly? And he said, I think so. So, let me just say for the rest of the world, what I think, and Andrew confirmed, was that this is this idea of really recognizing that your forecast can have more skill in some aspects of the solution, or you can have what Andrew thought was a window of opportunity. Sometimes when you get a certain forcing event, you're more confident in the projection that you're making than in others. So like spring barrier, right? We know that there are certain places where we have more confidence in our forecast. So starting to deliver that information, it apparently, so I haven't read this research myself, but in the meteorologists who are always ahead of us in oceanography, realize that naive users actually, I'm out of time, do make better decisions when they have probabilistic forecasts, even if they don't understand all the details of what those probabilities stem from. All right. So many different ways to use machine learning and these have already been articulated, from integrating different scales of measurements temporally and spatially, and also for forecast correction. So that was our discussion.
You can unmute whenever you're ready. Who's ever delivering the Breakout 3 Group D online?
Technically Group E, if that's it.
Oh, it's technically Group E, somebody says.
Yeah.
It's our online group.
Yes,
Michelle, Faye, and Stephanie. And if not, we can all read and contemplate your work.
E is virtual.
Yeah.
Oh,
E and F were combined.
next one's using.
Oh, virtual. That's a virtual. So who was D? That should be the other person.
Actually, yeah.
So did you have to slide?
That is better.
Oh, no, we only have one slide.
Or maybe they were not.
Okay.
Yeah, I was thinking.
What's that?
Anytime. So if anybody from Group E would like to unmute themselves from online, and you can turn on your camera if you like to.
Hey guys, it's Michelle Girock. So yeah, I'm presenting for the virtual group. So E and F were combined. Sorry, I don't know who D was. I was like, I can.
No worries, thank you, Michelle.
I don't really know. So for Group E, we had 16 people, which was great. So we sort of broke it down as others had done, and sorry for the numbering. But really going to the first question, so what were the major challenges? And we felt, and you've probably seen some of this with the previous, but there really is a challenge in combining these disparate data sources for a single variable, let's say, but also multiple. So as someone had mentioned, it really called for the need for best practices in data collection as well as processing for these. There also is a lack of access to global biogeochemical model output at the spatial and temporal scales needed for regional downscaling, and a great example was given with respect to the issue of downscaling for the IPCC 5 assessment. as well as seasonal prediction, and that only surface values currently are available for the ocean state. There was a need for multi-trophic level integrated data sets, and maybe we could go as far as saying a multi-trophic level observing system. There's a lack of understanding both mechanisms and processes of where this predictability actually comes from an ecological standpoint. There really is a challenge in linking the spatial and temporal scales of information. So that could be the different data sets, data that goes into these models provided from one piece of a coupled modeling system to the next. So if you go from physics to BGC to the ecological model, there's definitely a disconnect with respect to sort of the data information and their scales. So again, calling for the need for these standardized best practices in data collection and processing, and a great example was given in which that zooplankton was specifically brought up, that how it's recorded by the people in the field is actually as counts, but generally what modelers might need is in the, let's say, on the order of carbon of milligrams per meter cubed. There's also a need for a systematic approach to aggregate these data by system sensitivity or management question. And then we sort of got into this idea of you really need to have an idea of what the stakeholder needs are, whether that's qualitative or quantitative. And then when we got into sort of the discussion of machine learning and how this really could be leveraged, we felt that you could actually couple with probabilistic forecasting. You really, we sort of just got into the benefits potentially of doing this. So it really was stressed that if you really need to work with a knowledgeable computer scientist to actually optimize these techniques, and it's beneficial. We sort of talked about the benefits. So if you have, you don't really have to worry about the biases, and it is beneficial when you have these types of disparate data sets. And you could use machine learning to replicate sort of dynamical model behavior, which Lisa then told us could in fact be called, within her field, they sometimes say reduced form modeling. So we didn't know if it was the same, but it seemed it might be applicable here. So that is what Group E Virtual talked about.
I think that's it, unless anybody from this group wanted to speak up. I'm not sure if it's a duplicate or totally new.
It's a duplicate.
Okay. Well done, everybody. We have,
Okay,
we have about
breakout.
7, yep, we have a few minutes.
Yeah, well, I think we can.
Yes, Mike.
Yeah, I think if anybody has questions or to the people who reported, we can maybe ask them, or we can just directly to the breakout, to breakout 4. Okay.
Let me grab the mic.
Yeah, Ethan.
The idea of working closely with computer scientists has come up several times, and it's good. I wanted to add something on top of that, which is also the additional value of having people with wide disciplinary training. There's some people in various stages of their education right now who could be those people, and in some applications that we're talking about, the machine learning is being used in ways that are broadly used in industry and things like that. Categorizing images, right? There's a lot of different parts of the economy where that's, that technology is used. So there's a lot of expertise on that. Some of the other applications are really tied to an understanding of the science. And you can try to build a bridge with your collaborator, but at a certain point, individual people make the best bridges in being able to synthesize what the science needs and what the machine learning can offer, and really come up with the most creative solutions. So those of you in graduate school or going on to a postdoc to learn machine learning and stuff, I think that's really, really important. And we should do more of that.
Yeah, that's a very good point. Anybody else? Comments or questions?
I just wanted to make a comment because we've said many times that we need observations into a centralized database with a standard format. And I'm hearing this number of we need to plan for 20 to 25% of our budgets going towards that. I would caution against the expectation that observational oceanographers should dedicate 20 to 25% of their proposal budget to making these data available to the people who will then need it, right? I think that currently the format is that we expect them to make them available, and that sounds like it hasn't worked in many cases. So I think the same way observational oceanographers are not maintaining ships, perhaps we should think about the budget should be dedicated at the proposal time, but going towards experts in data management, right? Positions that will take the data and make sure it's formatted correctly, because having been a student with tons of data from a field campaign, I'm busy writing the paper, right? Not figuring out the format of everything, right? It's harder to train individual people in all groups than it is to have a centralized person to do that.
Okay, so somebody dedicated to working on curate the data and put them in the format that can be easily accessible instead of, yes, at the proposal level. Okay, anybody else? Okay. Yes, I think people are still working on the reports. Okay, good. I think the room is getting populated. That's what actually I suggested, because it's better to give people a little more time. I think that was also the suggestion.
You don't want to.
I don't think so. I think we should just do the breakout. Yes, because they're online already. Okay.
Unless,
So I think what it says.
okay, fair enough.
Let's get started. Okay. Okay, everybody. So we are going to start with the breakout reports, and this is Group A. You are?
Hello, everyone. I'm going to start with summarizing the notes from Group A. We had a really productive discussion. We'll start with the promising observational advances that we wanted to note. First were just the really amazing hyperspectral satellites, so the surface, like PACE and SWAT, that are coming up in the existing projects. We talked about how many advances there have been in lots of automated in-situ sampling. There are so many drones and AUVs that are coming out, like some here at HUI, like Clio. There are also things like the environmental sample processor and EVPs. There's been a lot of advances to automate flow cytometry and to automate omics and to automate all the traditional oceanographic measurements that we take. And we also brought up the idea of that there are now efforts being made by people like Erin Fischel to work on self-coordinating and self-localizing underwater swarms, to do adaptive sampling of oceanographic features as they happen dynamically. And we also talked about the ocean observatories that are out there and the LTR networks that are really great at generating consistent and prolonged data sets at specific areas that you can directly compare to models. And then we moved on to talk about prospects for measuring desirable variables. And we said we need more subsurface samples. We need more measurements of things like the chlorophyll max and bottom temperature that are chronically undersampled. And we also discussed, this is going on the whole conference, there's this trade-off, right, that you have to make between the depth and the breadth of the sampling that you make at temporal and spatial scales. And so that's always going to be there, and we have to be really mindful of that. And we also talked about, maybe we should also target physical variables that have the predictive skill to inform biogeochemical and ecological forecasting. Just focus on those predictive physical variables. And we also talked about chronically undersampled shallow and benthic habitats like estuaries and intertidal zones. And we also had this conversation about if we can get an understanding of the lags and the processes that are involved in an oceanographic feature, can we use that to predict the current state? And I think some people have incorporated this into their work. And then we had a conversation about leveraging coupled reanalysis products. We talked about how we can construct the physical relationships from reanalysis products that we trust, and we can test those again in the field. So there's kind of this balance here, right, between observations that can verify the models and models that can guide future observation efforts. And we also talked about how there are a range of machine learning and statistical learning and process knowledge techniques that can fill in gaps in time series and in models. And then we finally talked about the best strategies that we have for promoting data sharing and for creating integrated archives for data sharing. In the short term, we concluded that we should focus on effective data mining techniques that use algorithms, and AI techniques to minimize the amount of time that we spend on computers, like wrangling data and curating it from different data sets, right? And people brought up a bunch of really great examples, like the NCAR climate data guide as an example, and also like the Google PageRank algorithm and how that's evolved over time to really curate data from lots of different spaces for a person. And we need more products like that in the ecological forecasting space. And then in the long term, we need to just invest in positions and institutions between observationalists and modelers to oversee the standardization of data, to make data more available, and this in turn will support like Coastal or like open ocean reanalysis. And lastly, we need to create community standards that can be embraced by existing databases and enforced by agencies and journals, like the FAIR data standards, and making sure you have metadata and DOIs, and you're putting it on open source archives. But yeah, that's it.
I got nominated because I came up with the weirdest idea. So we talked about a lot of different things. The numbering changed, but 1.1 and 1.2 kind of were intertwined in our discussion, so I split some things that way. This isn't what we ended up with at all. So in terms of the promising advances, we're really excited about BGC Argo, the potential maybe to expand it to gliders and also build out coverage, for example, in this part of the world at key areas like the entrance to the Gulf of Maine, where we're not aware of this kind of sampling, but presumably a lot's going on that we'd like to learn about. So satellite observations, particularly excited about those two lines should be together, but how we're developing regionally optimized ways of retrieving satellite products. So the satellite products are getting more sophisticated themselves, and then how we use them is progressing at the same time. Another advance on the modeling side is not just having the variables that your model uses to have dynamics, but also calculating things, right? So if you have a bunch of phytoplankton terms, using radiative transfer to calculate ocean color so that the model has variables coming out of it that you can directly compare to observations, as a way to make the models closer to the measurements. One of the things we talked about was benthic flux data, and sort of one of the places where there's just really a lot of sensitivity in the answers we're getting and very little knowledge constraining it, right? So carbon, nitrogen, right? Those things happening in the sediments, and this can be in the deep ocean, but we were thinking a lot about just like Narragansett Bay, for example. Those are hard to measure. Those are hard to measure at high resolution, but they're really, really critical. One thing we talked about was maybe eDNA. People mean a lot of different things by eDNA. If you're talking to a fish biologist, they mean fish eDNA. Those can get us taxonomic resolution, some indices of community composition, but also maybe in the bio part of biogeochemistry, right, the actual components that are doing remineralization or transforming nitrogen between different species. And so maybe you need to do eDNA of taxa, but maybe you need to do it of actual functional genes. So eDNA of nitrogen reductase. And those being maybe the most accessible things to measure across space, and then try to map out that heterogeneity, because there's a lot of heterogeneity and it's not constrained whatsoever. So leverage a couple of that's very poor timing. Mr. Likely has called me again. Mr. Stan Likely. The goal of a lot of reanalysis products is to give us the best estimation of conditions, but we also want, particularly as reanalysis expands to new parts of the ocean in terms of components, right, as we start to include biogeochemistry, we need estimates of skill also. And this is a place where you can maybe bring together the different kinds of data and modeling and machine learning together, because all of these things can do cross-fold validation, right? So ultimately, you want to use all of your data to get the best estimation, but on the way there, you need to stop and say, if we pretend we haven't observed something, does our interpolation actually, give us something skillful? And then, so finally, in terms of data sharing, we need the DACs need to be brought closer to the scientists, and there's success stories of this. NASA, I think USGS has come up and Argo has come up. There are some success stories. They have very different organizational structure to a lot of the way DACs are used now. And so how can that bring the gap together? Because a lot of the DACs sort of have their own mission that is then, there's a very big divergence in sort of what the scientists need and what the DACs deliver, because they're driving their own truck down a totally different road. So anyways, we have a second version of this slide that we'll get in the right place.
So for Group C, we started with the reanalysis products first. So we thought that the comparisons between different reanalysis products were very useful, like what Dylan presented yesterday. Even though they're assimilating the same data, in theory, they can often differ substantially, and that can provide you a lot of information. Like the previous group, we thought it would be good to have information about uncertainty and, if appropriate, potential biases as well as skill coming from these reanalysis products. The high resolution reanalysis products, we think they're useful and can be helpful even in coastal regions. However, it still remains a challenge because a lot of these global products are not assimilating coastal data. We still think comparisons between reanalysis can be useful, and these more specialized regional reanalysis products can also help in this case. In terms of observational advantages, I think we have a lot of enthusiasm for BGC Argo and getting oxygen and pH data from that. However, there is a lot of worrisome biases from these data. So we would like to see good and standardized methods for correcting these biases, as well as maybe higher level standardized data products coming from these. LiDARs look like they may be promising for routine monitoring. I think we had a lot of East Coasters in our group, and we were kind of jealous of the West Coast, where their LiDARs are used for monitoring, follow straight lines, do the same thing every time. Whereas on the East Coast, it's been kind of, spaghetti following Gulf Stream, and just set out for like hurricane applications. We would like to see grazing rates and benthic fluxes, but we realize that these are very difficult and expensive to do. And we think that real-time data is especially critical when we're talking about nowcasts and short-term forecasts. So we need the data like as soon as possible, as soon as it's measured. In terms of strategies, we recognize that data access is still a problem, but trying to be optimistic, we think it's better than it used to be. It is still a little bit difficult in the coastal regions. I think one of our big recommendations is to make data available by APIs that will enable reproducible workflows. We think that the Copernicus service is a good example of how to do this. You can get a Python script that will download all of your data for you. You can share that Python script with someone else and they can get the exact same data that you have. When possible, we would recommend standardizing measurement methods and units. Things like rates, biogeochemical properties may be measured differently, measured in different units. That makes them hard to intercompare. We suggest organizing databases with properties that are relevant to end users, such as by the variable, rather than by things that are not relevant, like the project number. And finally, we thought that if they're not already, the regional associations may have a good role to play in terms of data quality control, as well as publication. So, thank you.
We have to download them all. We can't share from Google.
We had a very good discussion, and then we finally looked it over, and then I think we got most of it into the slides, but I'm not perfect.
We sent her from
This one? Yeah. That looks. Yes, great. Oh, yeah. So, yeah, we had a nice discussion. I'll go quickly here. What do we see as the most promising technological advances? We were excited about numerous prospects for improving the spatial temporal resolution on coastal ocean and BGC conditions, things like glider sail drones and aerial drones. Though we know that there's definitely still cost, reliability, and coordination challenges to meet. So we don't think that it's a panacea, but we were excited about the prospects there. And we talked a little bit also about leveraging industry partnerships for cost-effective sampling and sampling in the most relevant ways to the potential implications, whether it's lobster pots or ships of opportunity or offshore wind platforms. The variables, we kind of all agreed that a physical and BGC baseline would be a good starting point and also a tractable starting point. But that we also needed to take some bold leaps to provide similar spatiotemporal perspectives across the food web and for target organisms. So whether that was tags, optics, or targeted acoustics, eDNA was mentioned, although some real limitations were also identified. And we just generally know that the solutions at scale aren't clear, that these have proven useful in specific circumstances, but whether they could be part of a national framework that was applied everywhere was a bigger challenge. And generally a need to identify a core set of ecological forecasting variables across regions. To get from that kind of 34 core variables that were intended to serve a broad array of needs to what would the smaller set of core variables that we need for supporting a broad range of ecological forecasting applications would be a useful exercise. And, like I said, we sort of came up with a, physics BGC plus maybe a few innovative upper trophic level measurements that are really critical for making those mechanistic linkages, because in order to understand how fish, for example, respond to the environment, you need observations about the environment and the fish. For the physical biogeochemical reanalysis usage, I think we all noted that the oceans will always be sparsely observed directly, so that really the integration of models and data is now and will continue to be a critical way forward, and that we really shouldn't view the modeling investment and the observational investment as being in competition, but really as an integrated approach to understanding the ocean. We noted there's the difficulty in accessing the data sets required to build and evaluate reanalyses locally. But if we could do that, they have great potential to contribute to the mechanistic understanding challenge that was identified in our earlier discussions. And also, if they're skillful, could provide a great basis for some machine and deep learning approaches. Those are, data limited, but if we can show that these reanalysis products have a reliable reconstruction of these key variables, they could be used as the basis for some of those machine and deep learning approaches. Best strategy for promoting data sharing, we noted that's a big issue, and we need entities and folks to pull together disparate regional data sets to provide larger scale products nationally. A lot of the issues we face now are cross-boundary, and so we need to start really taking that step. We also noted there was a lot of angst in the room because it's a big job, right? Pulling these together and data sharing, and I don't think we all agree that it shouldn't fall on any one shoulder, and that not who should do it, but how do we come together to do it? So the data experts are absolutely critical, but if you have a data expert without a domain expert who actually knows, how the data were collected and what the domain are, it's not going to lead to the desired results. So we really need to figure out how do we come together to produce high quality data sets and deliver them. And we had Ginny in our group who has a great, sorry Ginny, I'm embarrassing you, but Ginny, of course, manages the Climate Observations and Monitoring Program, and that program does have some resources to maybe take some initial steps in these directions. So catch Ginny afterwards, or if there's time to discuss that program. When is the next call for proposals for that, Ginny? July. All right, so plenty of time. Yeah. So, I think that's about it. If I missed anything, anyone from the group, please chime in. I'm sure I missed things.
Okay, we have our online group next, so if you'd like to unmute, and I can bring a video over there if you want to turn on the camera.
Awesome. This is Laura Lilly. I have my video on, but I don't, whatever's easiest. So I'm speaking for the online group, and we also had great conversations. We brought up a lot of the same topics that everyone else did. I think we really appreciated thinking about some of the promises and potential for using what we already have and how to make that better. So that was neat. So I will just blaze through these things quickly. For question one, part one. So yeah, promising observational advances. We talked a lot about various autonomous instrumentation, some of which listed here. Certainly in situ optical imaging for definitely a lot of the biological side, and then potential for eDNA and metabarcoding approaches. We also talked about potential via improvements to data management, which has also come up a lot in this conference, and making data more available on shorter, more immediate timescales. All of that can kind of help us with our overall goal of forecasting. And then, as the previous group did, we also talked about some of the issues with some of these observations and predominantly scalability of technologies due to expenses and still a lot of kind of requirements for manual hands-on knowledge, since a lot of these are still in their infancies, but not insurmountable, we hope. And the second one, which variables would be most desirable? Again, a lot of things that have come up already. Near bottom variables, especially in estuaries and shelf coastal regions, and also fluxes into those regions. And we talked about, I think there is a lot of potential for measuring and kind of using a lot of these variables. We talked about how hatcheries, shellfish hatcheries, can actually use salinity as great proxies for ocean acidification events, instead of having to sort of make even more complicated measurements. So there's a lot of potential to bring in these kind of already available things to end users. We talked about wanting more information, again, on mechanisms and processes in the subsurface ocean, everything from currents to subsurface profiles on all stripes. And then we also talked about dark data recovery, so accessing data sets that may have never been digitized, or maybe just be sitting in someone's office. The possibility to bring those in as additional ways to validate reanalysis products and other opportunities there. And then, as has also come up in this conference, multi-trophic level measurements. In terms of the third question, we had a lot of great ideas here. One thing on kind of more the need side was something like for improving heat budgets, having adjusted temperature tendencies due to data assimilation. And then we also talked about this idea of when you are calibrating reanalysis products, so say you have to do a yearly adjustment to a product, can you take that adjustment and sort of use the difference that you have to incorporate as a means to infer, why you had to make that adjustment and kind of what additional processes were going on. And then in terms of for the final point, the best strategies for promoting data sharing, again, this was a big need. We noted that, data repositories do exist, notably through NOAA and NSF variously, but they still have a lot of scatter and a lot of kind of lack of cohesion. And so we advocate for across the community, both agencies and the scientists, to really have conversations about how to bring more interoperability and standardization, and how to sort of structure data more similarly. And then also having accountability for data documentation throughout the collection and curation process, not just sort of making the initial promise to post it and then having the final pressure, but really incorporating that need throughout your whole process. So I think that was everything. And yeah, thank you.
So I think we can have some time for a break now, and so maybe we can take 15 minutes and reconvene at 10:35. So we can relax for a moment before we go to the final discussion. Thank you.
Yeah, so the first thing, now do you see what I move? This one is also that, right? Just like this.
The exercise of doing it. I'm glad we did it together. Because they do exactly, and they come.
Okay, we are to the final stretch of this workshop. It's been a very intense 2 days, a lot of discussion, a lot of great presentation, great ideas put on the table. So, so we have seen kind of starting from day one, we explored these different sources of predictability in different regions. And so look, the good news is that there seem to be sources of predictability in all the regions that we have considered, which may or may not translate in prediction skills, but I think we need to work in that direction. I think we have also seen that there are some successful already applications of prediction ecosystem application exercises and successful, which really give us motivation to move forward. Those were kind of in specific regions. And also we have seen that we have like a good toolkit of, for several tools for exploring this ecological forecasting, including both dynamical models, large scale and regional, and also like this new, this exploding kind of empirical and machine learning techniques, which could be used in conjunction with the other models. And so, given all these tools and given some of the observation we have, although of course we are always eager for more, I think one vision that we can have for the upcoming 5+ years is maybe the development of a coastal forecasting system, coastal ecological forecasting system. So I think, like, maybe in this final discussion, we maybe can revisit some of this limitation that we have with this idea in mind. I think a central piece of all we do is the data, and that's, the data inform the creation of the models, provide boundary and initial conditions for the regional models, and are critical for the evaluation of the models, both as they are developed, but also if we do forecast for verification. If we don't have data, we cannot say what our, how good our forecast is. And so I think this morning actually it was obvious that there is a long list, and I think one idea that seemed to emerge, if kind of just summarizing or getting the essence of all the reports, one idea that has emerged is the importance of actually trying to leverage on the data sets that already exist, but if they were put in a format and in archives that are available to everybody. And so yesterday we had a presentation by one of the IU's directors, and so we see that actually these groups really collect a lot of data, and that would be really useful to all of us if this data were put in the same archives and we don't need to knock at the door of individual regions. And then I think also, we have seen all this big list of variables that would be useful. I think probably would be important maybe to really summarize or kind of come up with a maybe more concise list of what are the essential ones that are absolutely useful versus those that maybe we can wait on. And then the other aspects is the methodological aspects. So there are many differences in the way like models are run, like regional models are run. So we have heard about protocols that are used. But in particular, when it comes to forecasting, I think we have heard about the importance of probabilistic forecasting and the importance of assessment of uncertainty, or if we want to be on the positive side, as Clarissa was saying, of the significance of the forecast that we make. And that, to do that, actually, if you just, first we have to decide how to do that. So do we downscale every single member, or, so there is the choice to be made, but I think the problem can very easily get untractable because it must be too costly to run large ensemble of this very expensive regional model. So, and that's maybe is an area where leveraging on machine learning techniques or empirical models or emulators, I think, and combining the two sets of tools, I think would be potentially a very powerful way to move forward in that direction. Anyway, I think this is kind of the main ideas that I have. I don't know if other SOC member wants to add something, and then maybe we can try to discuss among us. And I asked Ginny, who is there, to also tell us something about her program at NOAA, which maybe can provide some input or some ideas about how to start moving in the direction of consolidating or integrating data sets that are already there somewhere.
Hey, can everybody hear me? I haven't used this yet. Yep, okay. So the Climate Observations and Monitoring Program is in the Climate Program Office, and it's a smaller program, so it can't tackle all of the challenges that we've raised, and there are other programs in the Climate Program Office that focus on different things. So COM focuses on data set development and analysis, and projects are typically for 3 years, and for 2 of those years, we guys usually focus on the data set development piece, and then the last year is usually spent
Ginny, we cannot hear you very well. Is it on?
Here?
That's better. Better this way, yes.
Okay. So there is both a development and analysis piece usually, and so some examples of things that we funded in the past few years. Jessica Lowe at GFDL is developing a pelagic size structure database to support biogeochemical modeling, and she's using that from many of the plankton or zooplankton imagers. And then we're funding 2 projects. One's being led by Seth Bashinsky, and one's being led by Brendan Carter, and they're focused on making BGC Argo data more usable for multiple communities. And so hopefully they'll be tackling some of those bias issues that have been raised in this workshop. So funding for synthesis projects is one, and typically they've targeted specific communities for the Climate Program Office, the Climate Modeling Community, or the climate monitoring community, and we can talk about how that intersects with ecological forecasting. And then there are other ways that I think programs can tackle this issue. One is thinking about how programs and agencies can facilitate more of these interdisciplinary conversations that specifically focus on formats and data standards. So maybe some discussion on at what level those should happen and how frequently, and move on. And then this third thing is thinking about how we develop data management language requirements in initiatives. And so how can we encourage APIs or more connections between PIs and data managers at agencies, or thinking about funding less projects, but funding kind of projects at higher levels to incorporate data scientists or data managers. So we've talked about different strategies, and so there are different ways that agencies can approach that, and the COM program can approach that specifically.
Ginny, which input would be useful for the program manager from our community?
Thinking about what data sets would have the most impact. So when you're thinking about an integrated data set, for what variable or process, what would be a high impact data set or product to have? Or, so that's one for developing a data set, or is there a community collaborative activity that would advance these conversations? I think those are the 2 that come to mind.
Any? Okay, Mike? Also, I would like to encourage the people online to raise their hands and maybe participate in the discussion.
So I was just going to ask if you can sponsor a workshop as part of what you said.
So typically we CPO sponsors workshops through US CLIVAR. And so you submit an application to US CLIVAR, and then the agencies review it, and then contribute funding towards it. There are other ways to solicit workshops that we could explore that we have not explored in the past.
Any other question in general, or any comment or input? Oh, sorry.
Well, since no one else is talking, this is Dimitri from the Analyst. I think there was many times in the past 2.5 days, where people have mentioned there's a lot of data available, but it's not accessible. And if there was some way to collect the various data sets and make them available in one place, I don't know how you encourage that. And the example that always comes to mind is the bathymetry, how difficult it used to be to construct a global bathymetry because not one single bathymetry was good in all the regions, and then a project like GAPCO took over, and now you have one place to go, and with a delay of about 1 year, they put together the best set of bathymetries, so you don't have to go chasing around. So if there was some way to collect various coastal data sets and put them in one place, and that they're accessible with one, not as separate little places and times, but I want all the measurements of oxygen from 1992 to present in the coastal regions, and I shouldn't have to go around chasing. So I think this has been said many times in many different ways, and also with some quality time.
Is it something that could be facilitated, Jimmy, by your program, or? Sorry.
So I'm not going to
Put you on the spot.
I'm not going to answer that, but I'm listening. I do, when I was kind of writing down kind of questions, one of the questions I had was, who has done this well in bringing together, data that the community is like, oh yes, this is amazing, I have no complaints. And so bathymetry, if anybody else has any other examples, we raised Argo as maybe a good example.
Yeah, I was going to say, Susan had a great example with Argo, I think, coming together in BGC Argo. I kind of wonder, we had the last discussion session highlighted a number of observations that people had high hopes for, right? And gliders just comes to mind as an obvious product that likely needs some synthesis, some bringing together at a national scale of different people that have been collecting this data, and some serious thinking about how you can transition to a real monitoring component in addition to this sort of event-based science and other applications that these have been used for. So I'm not in the glider program, but that seemed to be one that was percolating to the top an awful lot. And had that analogy with BGC Argo, but it obviously has some challenges to meet. Right? We were talking to Susan after it was next to Margie. We were all excited about this glider solution. And Margie had this sort of quizzical look on her face, a little skeptical, like, geez, sure, they're promising, but there's a lot of challenges before they move from what they're used for now to being that sort of backbone monitoring. Maybe a proposal, a workshop of that caliber would be useful for wrestling with this. And it also brought in the users, fisheries folks to say, is this actually going to prove useful if we can utilize this fish?
Hi, this is Dylan. Maybe just another example of an organization that has curated data well. I guess sort of my opinion is the Earth System Grid Framework. I know that CMIP has a lot of problems, but they did do a great job of co-locating a lot of different model simulations in one spot to have a uniform metadata, uniform variable names. It's all in one place. If you have the time and energy to download the data, it's in a very readable, easy format. And I know that Copernicus has followed a similar model to co-locate all EC and WF data in one place too. Chris wants that one.
I'll also say the LTRs, and like haven't been part of different LTRs and just being on the meetings, like the data people are there with the scientists on the meetings and they're talking to them and they're listening to all the science that's been made. And I've worked with California Current, Gulf of Alaska, Palmer LTR. It's always been very easy to get the data, and I think having the people that are taking care of it be there with the scientists and like working together from the beginning has been like really, really important for that. So that's another project that I think has done real well.
I'm just going to piggyback off of Chris's point because I worked on an LTR with Chris. And so this is a National Science Foundation funded program, which requires you to write in your data manager into your proposal. So that's why they're in the room. The funder requires you to write that into your proposal from the very beginning. So that's maybe a tool that other agencies could potentially follow. Oh yeah, and in the case of...
Maybe repeat the question.
Okay, so Chris mentioned that some of the LTR sites will actually share data managers. So in some of the ones we worked on, in the case of California Current and the Palmer Antarctica LTR sites, it's the same information manager working with the data sets from those two different sites. So those go through some of the same processes and get served in some of the same places. So there's a bit of uniformity there as well.
And maybe an alternative or a different flavor of data curation that we discussed in our subgroup, we mentioned in the summary, was instead of forcing all these different organizations to adhere to a certain format, it could be solved on one level by creating some sort of machine learning or AI that is able to go in, download the data from wherever it is, and then convert it to what you need in a usable format. I mean, Google does this with search engines, in very intelligent ways that I'm not volunteering, by the way. But you could envision a search engine type thing where you type in SST and it draws down all the SST data you can find, and on the fly, it sort of converts it into a uniform format that we can use. I mean, that's obviously pie in the sky, but that could solve a lot of these stovepiping that we have across organizations where people want to have their data where they have it. Instead of creating infrastructure that doesn't exist, we could create programming like smart, intelligent search engines to bridge the gaps between. For what it's worth, the NCAR Climate Data Guide already sort of does this for climate data. Oh, really? Yeah, I mean, to some extent, it's more like a Wikipedia page, but you can go on the NCAR Climate Data Guide and you can search ERSST, and it'll take you to a page that tells you everything about ERSST, its uncertainties, its limitations, its uses, and then it'll give you 5 different links of where you can go download it. And that's true of a lot of different data sets. I mean, that's just one example, but it is a very useful tool, and I think it, again, is a useful template that could be followed for a lot of data sets.
Because I keep hearing that the LTER data sets are great, if I go on the website and I click data, I have to click on individual files. They're not netcdf, which means that the labels don't go with the variables. I don't see the interface to download all of the data sets. So where is that?
I did say they're perfect.
So the data, but then it's a micro step to get it to a format where you click download all data from this date to that date, lat long.
It has come a long way. So when I started also downloading like Excel sheets after Excel of like chlorophyll with personal notes to where it is now, it has come a long way. And also you can, what I think is interesting is that you can search for like different variables or different processes, or like this is the realm of things that I'm thinking of, like you can go there and download. There's still good.
But it's point and click, right?
Yes.
It's all point and click.
Yes, what I mean is that it's in the same page, it's all there, and it's standardized between the different, some of it between the different projects. So that's already way better than anything else I've had to do. I agree that a lot of the times it's missing metadata, and it could be on a format that's friendlier to modelers, but a lot of people do prefer Excel or CSV, or you have it, so.
Or friendly to big data analysis, right?
So, I have an observation that pertains to this conversation, and I think, drawing on experience like with the NSF EarthCube project, or funding stream, NSF had this idea of sort of unifying analysis workflows, or getting these projects funded to basically build kind of data analytics infrastructure appropriate for the geosciences. And they had this vision of funding these projects and having these people kind of develop synthetic outcomes across the collection of projects. And to a large extent, that really hasn't happened, because everybody's like, well, we're doing this cool thing and you should come work with us, right? And that just doesn't yield an integrated community. I think some of this conversation about trying to harmonize data management is probably barking up the wrong tree, in the sense that we're just not going to be able to attain a unified approach to data management, because each LTR or each institution is going to kind of be siloed to an extent, in the sense that they're trying to serve what they perceive as their users' needs. And so I think the actual place that we should probably focus our energy is on community solutions to synthesize information from disparate sources. And I think a nice model for that is actually the Pangeo Forge project, which is led by Ryan Abernathy at Columbia. And the idea there is that you're not, that you rely on sort of public access portals, but then you couple that access point with a framework that enables you to invoke a workflow, such that you kind of encapsulate all the messy details of a particular data set or format, and you can yield sort of a harmonized data product by virtue of curating this community repository of recipes that bring data into a common framework. So I think that, to me, is a really compelling community project, because it's tractable. We can crowdsource it, and we can ultimately evolve towards a gold standard, that could be adopted upstream. But I think thinking about it in terms of that synthesis piece is a much more productive angle than trying to solve the problem upstream first. Oh, and Charlie asked me to mention that all data should be accessible via APIs.
I was just giving him a hard time, but thank you. Another just a thought was, the successful examples, I think, all had very intentional ideas for types of data that they needed, the problem that they were trying to address. You think of CMIP, those variable data sets were developed for very specific problems in mind. And that's what led to this sort of standardized variable names, standardized approaches. These are the things we're prioritizing. The same thing was true of BGC Argo. And so I think it brings us back to this, what's the core data set for ecological forecasting that we need everywhere. And then of course, yes, there's a lot of granularity that develops with local applications. But I would argue or our group sort of argued for, yes, absolutely, starting with that ocean and biogeochemical underpinning for ecosystem stressors, ecosystem drivers, and then building off of that. But if we can develop that what do those core data sets look like? Then we know how big the problem is. What are the pieces we need to bring into the table? And I would say we've got to get much closer to maybe 8 core variables than 34. And CNEP has tier 1, tier 2, tier 3. You're always sure tier 1 is going to be there. And then, yeah, if you can get tier 2 and tier 3, great. But you can be sure tier 1 is going to be there, and this is most probably useful. So, I don't know if there's been published work on that, but it seems like we could probably reach a consensus on that. Maybe with a workshop, but I'll say until we do that, we're going to just find ourselves, chasing diverse data sets and kind of connect the dots. So.
I just have a question about this. Are the hackathons a useful activity to kind of crowdsource those workflows? Like would a hackathon focused on this activity be something that would contribute to that kind of effort?
I would endorse Charlie's idea in the sense that if we can clearly formulate research questions and couple those with requirements in the context of key variables, then to the extent that infrastructure exists, but it's just not well synthesized, for instance, then yeah, a hackathon could be great.
So would the hackathon require some knowledge of computing like Python or that not everybody may have? So for a hackathon, you were suggesting. So do people who attend it need to have some knowledge or some skills that are needed for successfully passing?
Yes. Yeah.
Let's see a question online by Aaron. Do you want to unmute yourself and possibly turn on your camera? I think it's Aaron. It's either Aaron or Al.
No, actually, it's
Al.
Yes.
Well, hey, I have a slightly technical question, perhaps, but many of us as modelers are very fond of OpenDAP as a protocol for hosting, accessing nice gridded model data. ERDAP was supposed to be, as I understood it, kind of the equivalent for observational data as an easy way to get to it from, say, a MATLAB script or a Ferret script, whatever you use, a nice direct access. It hasn't quite worked out, at least with some software. I wondered if other people in this group have had any experience with ERDAP. Is it a useful protocol as a general way of serving observational data?
Hi, I'm Elise Wilson. I have used that both for accessing model data and observational data from Python, and I find it really convenient because I can practically.
Sorry, I can't hear you.
Sorry. Can you hear me now?
Yes.
I have used ERDAP for both accessing observational and model output and using Python libraries, and it's as if the data is on my computer as long as I have a good internet connection. I think it's great.
So is that sort of becoming a standard for serving data? Is that just the sort of thing that would be most useful for these sorts of purposes, or do people see a big downside there?
To me, the biggest risk is that the data might change. And so as long as people are conscientious about taking good care of the data that they're serving, I think it's great.
For those not familiar with it, it's kind of the idea is to have a unique web address for individual bits of data that you can just plug into your software and get to it, and then you can build a front end that allows you to search and select. So in theory, it could solve a lot of these problems, but yeah, I'm just curious whether it's really catching on as a standard.
Yeah, Desiree Tomazi here. I think on the West Coast, EarthUp has been useful definitely to me to get observational data. And I guess people that also spend time developing, like use our code to download data and have been sharing it. So I think code repository to access EarthUp or other archives is also something that we need to think about. But then APIs are very nice too. So not a computer scientist, not sure what's the best item, but for large maybe models output, I think API it's nice.
Okay, just wanted to throw that out there.
Was maybe a small center. That's Al, is your hand still up, or are we? Oh, there it goes. This may be a bit of a change in tack here, but I found myself thinking this morning about what are the key decisions that we want to inform with this ecological forecasting exercise. And I remember, Desiree, I don't know if you remember this, but when you first started doing your project at Seasonal Prediction, we sat by a whiteboard and we came up with about 15 things that we thought we could predict. And we didn't know what to pick, and I said, well, which of these would actually impact the decision that was being made? And then all of a sudden we went from 15 to 2. And so it was great. I guess Desiree knew she could not spend 15 years doing it, but just the year of funding we had. But I think that's, from the application session on the first day, I think even for some of these sort of canonical applications, harmful algal blooms and so forth, we still struggle with what do we do with this information? We put it out there, it's informative, but I think if we're going to make a compelling case to move a lot of these things forward, we have to make a compelling case that these forecasts are going to broadly inform important decisions. And what are those? I've been focused on fisheries for a long time, and I do think those exist, but those should be driving up our thinking about what the core variables are, what the key timescales are. Do people feel comfortable with where that's under? Is it generating the same kind of angst for you that it is for me at times?
I think that's an excellent question. I think it's we have covered many time scales, and clearly there is need at different time scales, but what are more relevant? So there is a need for variables that can constrain the models and help with the predictions, and but also maybe selection of the variables that are more important for informing decisions. So of course, it can be a subset of what is needed for the prediction itself.
So, I think I know the answer to your question. But I think the answer is actually the answer is that it's about how, not what. And so I think it's clarifying to think about what the right sort of socio-technical network, like what is the composition of people and tools to assemble that is capable of developing adaptive solutions to the problem that you're posing. And I've been inspired, working at NCAR, we developed an Earth system model in collaboration with the community, which is nominally comprised of university PIs. And there's a working group structure that includes foci on the land and ocean, and each of the component models, and then some sort of hierarchy that feeds up to the top, and some executive decision making on behalf of the chief, by the chief scientist. But I can see a community like this being able to leverage some key developments in recent years, which is one of which is that NCAR and GFDL are now developing the same ocean model and are capable of developing forecasts and integrations in a very common framework with details that yield some degree of difference that is appropriate for sampling uncertainty. And then we sort of need leadership in different aspects of the problem, one of which is sort of connecting to stakeholders or identifying sort of relevance. But then we also need people down in the trenches, like working on numerical schemes and parameterizations of various processes, et cetera. And so I think in order to span kind of that range, that dynamical range, requires collective, some degree of organization, which is to say there's leadership and working groups that have particular foci, but then they come together and interact in the context of a common goal.
I think also the other dimension of the problem in terms of the use is what can be predicted. For example, like in green stock, maybe you cannot predict a single fish species, but maybe you can predict different fish categories, like she was talking. So I think that's another another dimension to consider when you think about who's going to be using the forecast.
Yeah, I agree. I just think, considering the outcome of this workshop, the specifics of what can be predicted is sort of an ephemeral concept. Whereas if our contribution is a lasting legacy in a community network that is coming together and continuing to share information, continuing to work with, work to advance a common set of tools, then that's a really compelling prospect in my view.
And also, this is not something that can be done right now. I mean, it takes, it's going to be developed by a number of years, where maybe what the limitations, the needs, the tools, and the demand may vary, may change.
Well, I think that also, to some extent, that framework kind of encompasses some of our individual discussions on, for example, integrating groups in weather forecasting that are super used to doing probabilistic or conditional forecast scale, or so maybe that ecological forecasts haven't, for the most part, been there yet. But bringing those groups together on specific topics, as a community, is the way to move forward and develop these best practices. And so, we have a whole bullet list of different kinds of topics where, integrating different fields, I think, would move us forward nicely.
And I think also, expanding this community to integrate more other folks who we think are going to use the data is going to be really important. So, there's not a lot of the people that we are envisioning using the data here or inputting it in their biological models. So I think that's going to be important. Because also this data is not really, in terms of the forecasting, is not yet, I think, readily available. That if somebody that is doing a stock assessment, and wanted to go use a forecast of SSH, it's not a place that they can go and say, okay, I'm gonna go here and get the hindcast and get the forecast and see if you make a difference in my model or not. So, yeah.
I was thinking about what I said last time, and I didn't mean to be too pessimistic about it. I just, I know that everyone in this room is thinking about the challenges and why they do ecological forecasting, and I do think, for instance, when I think about the multi-annual Decadal scale, I think the classic problem of when is this legacy fishery stock, is it gone or will it come back? And that's a critical challenge we need to answer for resilient marine resources. When I think about interannual, I think about stock assessment. How do we manage volatile fisheries? And so that there are these questions for each, but I think that we need to kind of bring those to the forefront in our thinking in every aspect of the design and execution of this, and have it out front as we try and build up this ecological forecasting framework. The other thing that I'll mention with the community is that, it's interesting. So I did my graduate school work was partly funded by NOS, and it was the ecological forecasting problem. They, of course, they have a vibrant ecological forecasting community that's been focused on maybe a smaller subset of problems that we're trying to think about here. And I think part of this workshop was trying to bring together folks who have been working with NOS on short-term forecasting of halves and hypoxia, and folks who have been thinking more on the climate scale, CLIVAR and so forth, on seasonal to multi-annual and so forth. So I guess we'll need to think carefully about when we think about building a community. It's more broadening and generalizing the community to take advantage of the full suite of opportunities that we're going to have. And I know that I think we need to hopefully after this reach out to those NOS folks with a little bit more intentionality to not reinvent the wheel here, but figure out how we can integrate the climate scale pieces with the other pieces, because they have done a lot of thinking on this front.
So going back to this again, so you were suggesting that, let's say, fisheries, so they definitely could use some of this information. So would you bring them in start being part of the conversation? Or if somebody would translate what maybe the scientists find to quantities that could be directly used by the fisheries, or so what would be your vision on that?
Yeah, I think there needs to be, I guess, just more communication between the oceanography community maybe, and then just the fisheries community in general. But I guess probably just having at least a few people that can kind of walk between, communicate between the two communities. I think those would be essential. And then just, once the data is out there, just making sure that it's accessible to folks that are not into, producing it. And we talked about it, we have archives, code to access the data. I mean, accessing the NMME output, it's not straightforward for somebody that has not really worked in one of the labs that has been producing the data. So, yeah.
Thank you. Point. The energy level is decaying. Yes.
So since we were talking about bringing forecasting users into discussion, I just wanted to suggest an idea that it's also useful to understand.
Yes.
Okay, since we're talking about bringing forecast users into discussion, I wanted to suggest it's also useful to understand that forecast users may have biases. So we talked about model biases and observation biases, but how your forecast gets used can be unpredictable as well. Like we know that many people are very risk averse, and they would rather spend money than lose money, for example. So bringing that forecast users into discussion can be helpful to understand how you need to communicate your forecast. To help them make better decisions and so on.
I'll toss something else in, which is the value of forecasting connected to users and stakeholders. That's a little bit of an end unto itself, which is that really forecasting in observational science is one of the only ways we can really validate the ultimate science in the models, right? We can't go out and do perturbation experiments in a lot of the large-scale ways. I mean, we sometimes do them by going out and catching way too many fish. We want to develop models to support trade-off analyses, decision-making that doesn't necessarily directly need forecasting. But focusing on the forecasting in the science lets us actually have some confidence in the model that the trade-off isn't just some fit to data or some combination of parameters that we pulled off of a bunch of different reports that measured one rate in one lab with one organism. Right. We want to test a model to see if it can actually predict real data. If we're going to use it to try to predict real trade-offs, real decisions. So, forecasting itself doesn't have to have a user to be important and serve users.
Do you have a question? Yeah.
Oh, yeah, I just wanted to say, as someone new to the space, I heard about so many tools and events and different initiatives that were all going on in parallel, and I don't want this to be end. I'd love to know about ongoing workshops or seminar series that are maybe happening in your department where you're sharing tools, you're sharing ideas, and you're sharing different ways you're accessing data. And I just wanted to plug two of them. I don't know if probably most of you know, but there's this thing called the Ecological Forecasting Initiative. It's an NSF project, and they're having a virtual conference in May. I hope to see some of you there. It's happening virtually, but I hope to see some of you there virtually. And they also have this statistical methods seminar series, and they talk about statistical methods they use for ecological forecasting. It happens on every first Monday of the month. So yeah, I hope this doesn't just end here, and that we all get to keep talking. I really love the idea of a hackathon or maybe some working groups where we continue to share all these tools and resources that we know about.
Yeah, I think the question will be how to really move forward in using this community effort. Really, I agree with Mark about the need of having a community effort. I think also, all the methodological approaches that we have discussed, particularly the empirical ones, try to intercompare them or assess what we can get from the different approaches, establish how many data we need for them, and how reliable they are, or whether they are worth fitting, or you can trust them. So I think these are all aspects that need to be put into need to be considered, and that we really need to work on as a community. I don't think it's a task for an individual or a small group. I think it's a community effort. Anyway, any other comments that people have, both online and here? Okay.
Just one comment that hasn't been mentioned, but I think is worth noting, is that the urgency for this enterprise is growing, both in the context of the pressure of climate change on natural resources, but as well as the diversification of human use patterns in the coastal zone. So, for example, things like offshore wind or ocean carbon dioxide removal interventions. As carbon markets become non-voluntary, essentially, there will be people trying to grow kelp or add alkalinity to seawater in variety of places. That poses a whole another set of scientific questions about whether those techniques are effective at doing what they're purporting to do, but it also has risks of ecosystem disruption. And I think that's really compelling in the sense that we really need to have our act together quite quickly to be able to provide scientific guidance for those efforts, which could also be critical for mitigating climate change. And so it's really, those problems are really intersect a broad segment of societally relevant issues. So I just wanted to add that context.
Yeah, I totally agree. I think here we're talking about ecological forecasting, but people are interested in CLIVAR. That's a very compelling and urgent issue. And then we are seeing the development of offshore wind farms, which also need some forecast or need interactions and their effect on the ecosystem. And ultimately, the forecasting system is one. I think with one forecasting system, we can address all these different needs. And so, yeah, I totally agree that it's a very urgent need. And I think we have the pieces to tackle it. It's not going to happen overnight, but I think we've seen here already so much expertise that can be used to move forward in this direction. So, okay, this seems like a good way to conclude the workshop with this, on this positive note. So I think the next step on this is the Scientific Organizing Committee will prepare a report. And if anybody is interested in participating, just let us know, or we may reach out to some of you for clarification or maybe for some additional information that we may need. And yeah, so we'll be in touch, and of course feel free to reach to anyone else if you have additional ideas or thoughts that would be useful. I think we would love to hear from you. So thank you so much for participating either in person or virtually. I think it's been for me really wonderful 2.5 days. I think I learned a lot and I realized how much we have and how much we can do as a community. And before we close, I would actually like again to thank our sponsors, but also very, very heartfelt thank to the organizing committee, Eder, May, Jimmy, Mike, and Mary somewhere. I think really they have been fantastic and really made all of this happen. So thank you all.
Thank you, Antoniette, for organizing the very clear.
Yeah,